Alrighty, good morning everybody. Mr. Motohun here. Continuing our study of logarithms. Last week you were introduced to the basic idea of a logarithm and how it's kind of the opposite or the inverse of an exponential function. And so just like with exponents, there were a couple of properties. You're going to see that logs also have a couple of special properties as well. So that's the topic for today. And then in this video specifically, after we derive some of these properties, I'm going to focus on condensing because that's your first Delta Math assignment, and then I'll come back to expanding. Okay, so you might remember with exponents, they had a couple of rules. So you might remember if you had x to the a power times x to the b power, we would add those exponents together. You may also remember if we had x to the a power divided by x to the b power, that would be subtraction. And you may also remember that if we had x to the a power to the b power, that would just be multiplying those two powers together. And honestly, if you understand these exponential rules, they are literally pretty much identical, very, very similar when it comes to working with logs. So I'm going to go ahead and focus on the multiplication property for a second. So this is the log that we're looking at, log base 3 of 27. And one thing that I want you to realize is we could actually solve this log right now. If you remember from last time, right, pretty much all this is asking is if I took 3 to what power would I get 27? So I can rewrite this like this. And if you know your exponents well enough, it shouldn't be too hard to come to the answer of 3. Okay, so again, that's not the point of this lecture. This is just to show particular properties. So what I want to bring to your attention is this 27. So right now it says 27, but I wanted to show you, since this is the multiplication rule, I want to see if we can express 27 as a multiplication. So I'm going to go ahead and keep the same thing, log base 3. Sorry, that's a 3. Log base 3. But inside of the parentheses, I want to go ahead and express this as maybe 9 times 3, right? Which is also 27. And I want you to realize that we could actually split this into 2 logs. So we can have log base, oh, I should have left it black, sorry. So we can split this into log base 3 and log base 3. So I'm going to keep the colors just so that you can separate them in your mind. Okay, so we know that our answer is 3. We know that's what we're trying to get to. But I want to see if we can work with these 2 logs separately or individually and see if we can still come to an answer of 3. So let's go ahead and look at this first log. So log base 3 of 3. And again, you should be able to pretty quickly solve that in your head because this is pretty much asking 3 to what power is 9. And if you know your powers well enough, you'll be able to see that that's 2. And then using very similar logic, you should be able to do this log in your head. It's pretty much asking 3 to what power is 3. And again, if you know your exponents well enough, you should be able to come to an answer of 1. So now we're looking at the numbers 2 and 1, and we're trying to figure out how we can get 3. So I'll go ahead and write it here. We know 2, we know 1. What can we do to turn those numbers into 3? And voila, plus. So I hope you're seeing that we can split a log into 2 smaller logs and still end up with the same answer as long as we add. And again, I'm trying to show you that we already knew that it was going to be addition because we knew the rule for the exponents, which said when we have multiplication inside, it turns to addition. So same idea here. Okay, we'll do one more example. Let's say we had log base 2 of 8. So log base 2 of 8. Again, this is a log that you should be able to solve pretty easily with no issue. This is pretty much asking 2 to what power is 8. And again, if you know your exponents well enough, you'll be able to see very quickly that the exponent you want is 3. So again, I'm going to say, let's go ahead and think, what if we broke that down? So let's say we broke it down into log base 2 of, let's do 2 times 4. 2 times 4. Okay, so again, could we split this up into 2 logs? Let's see. So we can split this into log base 2 of 2 and log base 2 of 4. And again, these are pretty straightforward logs that we should be able to do separately. So log base 2 of 2. Well, again, this is just saying 2 to what power is 2? Well, 1, right? Anything to the first power is itself. And then this one is saying 2 to what power is 4, which is 2. So again, our goal is to get 3 as an answer. That's what we know the answer is. So if we have 1 and we have 2, what can we do to them to get 3? And again, we see addition. Okay, so I'm hoping that you're seeing, just like with exponent rules, there is a log rule that has to do with multiplication. So I'll go ahead and write it here for you now. So the log rule says, let me just undo this exponent rule. So very similar to the exponent rule, it says if you have log of some multiplication, so there's some multiplication going on inside, say between A and B, then pretty much this is the same thing as writing it as 2 separate logs and just like you would think for the exponent rule, we're going to go ahead and put a plus sign in between. So just like we said before, multiplication becomes addition. Multiplication within one log becomes addition in 2 logs. So I'll write that. Multiplication inside of one log becomes addition of 2 separate logs. Okay, so that is our first rule, the multiplication rule. And I'll do a couple examples to show you how to use it. Okay, then we go to our division rule. So just like exponents had a division rule, logs do as well, since they're pretty much the same thing. So we'll start with this example. And this one says log base 2 of 16. And again, I'm not trying to trick you. I'm not trying to, make anything more complicated. This is a log you could do right now off the top of your head. You would just have to ask yourself 2 to what power is 16. And again, if you know your powers well enough, you would be able to know we're looking for an answer of 4. So again, in this case, in the first set, we were turning this inside into multiplication. Now we're going to turn it into division. So let me just think of two things that I could multiply to get 16. And I'm thinking 32 and 2. So let's say I had log base 2 of 32 over 2. Okay, and I'm going to go ahead and look at these logs separately. So, okay, log base 2 of 32 and log base 2 of 2. Okay, so this one, I can solve this log if I just think 2 to what power is 32, and I believe that's going to be 5. And this one, I can figure it out if I ask 2 to what power is 2. And that one should be pretty straightforward because we know that we can get the same value back with a power of 1. Okay, so I see that the first log got me 5, the second log got me 1, and I know that I want my answer to be 4. So how could I use the numbers 5 and 1? What could I do to them and end up with 4? And hopefully you're thinking subtract. Okay, so another way we could write this is we could say log base 2 of 32 minus log base 2 of 2 equals 4. Okay, let's look at this one right here. Log base 3 of 9. Again, no tricks, no secrets. You could do this right now if you wanted to. Log base 3 of 9. This is just saying 3 to what power is 9. And again, if you know your powers, 3 to the first, 3 to the second, 3 to the third, you've got a power of 2. That's the second power. Okay, but I want to break this up, so we're going to turn it into division. So let's think, what could we divide and get 9? I could do, what could I do? I could do 81 and 9. And if I split this up, I'm going to have to figure out what is log base 3 of 81 and what is log base 3 of 9. So if I just think for a second, I'll be like 3 to what power is 81? And again, if you know your powers well enough, that'll be 4. This one is 3 to what power is 9? That's 2, just like we said over here. So the question becomes, what could I do to the values 4 and 2 and end up with 2? And it has to still be consistent with what we did up here. So if we subtracted, does it still work here? Is 4 minus 2, 2? Yes. So again, we're seeing that we could also write this as maybe something like that. So that brings us to our division rule, which is very similar to this exponent division rule. It looks very similar. So pretty much what the division rule says is if there is division in a log, so let's say you had log of, I don't know, something over something else. Well, the exponent rule said if you had division, that turned into subtraction. Same thing here. If you have division inside of a log, that turns into subtraction between two logs. So division within one log becomes subtraction between two